So this is the last part of the 2011 linear regression question. This is question 4 from 2011 for business statistics. Calculate a 95% confidence interval for the slope of the line. So first off, actually, let's just remind ourselves what the slope of the equation was. So y hat, the estimate for y, was equal to 20.73 minus 0.46x. Now, so just as a quick remark, this is what this value here is what we are looking to find a confidence interval for. So that's going to be the point estimate. So the point estimate is the slope, which is b0, okay? And that is the first part of our 95% confidence interval. So just to remind ourselves what the general structure of confidence interval is, it is the point estimate plus or minus quantile times standard error. Okay, so we've already got the first part here, the confidence, the point. Undo that. We already got the first part of it there, the confidence, the point estimate, which is 0.46. So that bit's done. Now the quantile we'll just talk about briefly now. So the quantile is just a couple of remarks on the quantile. We have a small sample size. Actually, just as a remark, n was equal to 10. There was 10 cases involved. So small sample size. Now it's a 95% confidence interval, so alpha is going to be 0.05. And we're going to use the t distribution. And just as a remark, when this is different from hypothesis testing and so on. When we're dealing with linear regression, the degrees of freedom is always equal to n minus 2. Okay? When we're talking about linear regression and so on. So it's n minus 2, not n minus 1. In that case, that means it's going to be 8, which is to sort of say n minus 2 is 8. Okay, now we have to sort of go to the tables here and find out what that is. Now, just as another remark, the 95% confidence intervals, you actually work on the basis of a two-tailed procedure. So what we're going to do here is we're going to go to our statistical tables, and we are going to go to so this is the T tables. Okay. Now in the Murdoch-Barnes set of tables, which you should be using, this is table 7. Okay. So what we're going to go down do is we're going to go down to row 8 for degrees of freedom is 8, and because it's a 95% confidence interval, the column we're going to use is 0.025. Okay, and as a result of that's because we're using how should I put this? 0.05 divided by 2 is how we calculate that, which is to say the alpha divided by 2, because it's a two-tailed procedure. And the answer we get is 2.036. I'll just check my tables here. 2.036. Sorry, 2.306 is the quantile we're going to be using. So 2.306. So this is the quantile from the tables that we need for this question. 2.306. So let's go back here. That's the second part of the calculation done, and where we find out the quantile. So that's that part done. So now all we have to do is compute the standard error. Now, this standard error is a three-step procedure here. So we have to. This is the main calculation here. This part up here, and this comes from this formula is given to you in the back of that exam paper. But it actually is comprised of multiple parts. So it actually it's a three-step process to calculate it. So what we're going to do is start off with this last term here, SSE, which is reasonably straightforward enough to calculate, and then we'll work back. So let's start here now with there. So SYY, so first off, SSE, that's equal to SYY minus B1 times SXY. Okay. So what we're going to do, what we do here is like that 148.9 minus 0.46 times SXY, which is, sorry, we have two minus signs here. And also we're going to multiply that by another minus value, 2.8 or 283.8. So we have a minus times a minus times a minus. So it's a triple negative. So anyway, so just to simplify it, 148.9, just to take out the triple negative, is 0.46 times 283.8. Okay, and working that out in your calculator, you should get a value of 18. No, 17.454. Okay. Now, just as a quick remark, the rounding error comes into this a lot. So if you're getting numbers that are a good bit different, or a little bit different from 17.54, something like 17.5 or something like that, don't worry too much about it. It is just a small matter of rounding error. After a while, the calculations, the effective rounding error goes back, so it works back, so that you usually end up at the same place as everyone else, even if you've gone different ways. So that's the first part there. SSE is 17.545. Now we're going to compute S squared here. S squared is simply SSE divided by n minus 2. That's 17.454 divided by 2, or sorry, divided by 8. And that is, again, a little bit of calculator work, and I make that out to be 2.182. And again, just to be clear, rounding error comes into play quite a lot. So if you get an answer that's roughly approximate to that, that's fine. The last part is the standard error of B, which is this part here. So we're going to divide S squared by the square root of Sx. So let's clear the screen here now. So the standard error of B is, we're going to calculate it as follows. It is S squared, which we found to be 2.182. Standard error of B1 is the square root of 2.182, and we're going to divide that by Sxx, which is 613.6, this value here. Okay, now working that out, I get a value of 0.06 approximately, and again you should get an answer reasonably close to that, and just to sort of take into account the rounding error that takes place. So 0.06. Now we're able to put everything together now. So the point estimate plus or minus quantile times standard error. So that's minus 0.46 plus or minus 2.306 times 0.06. That's equal to 0.46 plus or minus, what's that now? 0.1383, and roughly that is equal to minus 0.324. Again, I'll just round it to 3 decimal places in this case, to minus 0. Actually, I should have gone the other way around. Minus 0.6014. I'll just go to 4 decimal places anyway. To minus 0.3246. So that is, again, the reason that things move slightly is just like the way I deal with rounding error. I'm actually reading from a page where I just got numbers that are slightly longer than what I have in front of you there. So that is the answer to the confidence interval question, or the confidence interval for the slope. It's quite a long question. You need to be sort of smart with tables and stuff like that, and know the general structure of a confidence interval. That's also quite important. That one there, that's always quite important. Another thing, actually, just to remember is degrees of freedom is n minus 2 when dealing with the slope of the line. Okay, so that ends the presentation.